So by now you should know how to square radicals. And what this is really good for is actually using it to help us find the length of triangles using the Pythagorean theorem. So we're going to use our squaring radical skills to help us solve problems using the Pythagorean theorem. Okay, so let's do some examples. Say like we have a triangle. It's a right triangle. And sorry, that's not straight. Okay. Say like the length of this side is square root of 2, and the length of this side is square root of 3, and we're solving for the hypotenuse. How do we do this? Well, let's start off with our formula, which is a squared plus b squared equals c squared. Let's plug in one of the lengths of the sides of the triangle in for a. So we have square root of 2, but notice it's squared. We have square root of 3 right here. Let's plug it in for b. And notice it's squared also. And then we're trying to solve for c. Okay? So we just learned in the previous section of this video that anytime that you square a square root, you end up just getting whatever is under the radical. So this simplifies. The square root is canceled out by the square, and this just becomes 2. The square root here is canceled out by the square, so we just get 3 equals c squared. And then we can go ahead and combine like terms. So 2 plus 3 is 5 equals c squared. And to get c by itself, we do the opposite of square, which is square root. And we do the square root here. And so we get c equals square root of 5. And 5 can't be simplified any further, and so this is our answer. Okay, I'm going to do one more example. And this time, instead of trying to solve for the hypotenuse, we're going to try to solve for the leg. So let's say I have this right triangle, and the hypotenuse is square root of 13. And the length of one of the sides is square root of 5. And we're looking for x here. Okay, so, oops, sorry about that. Okay, so I'm going to go ahead and write my formula again. A squared plus b squared equals c squared. And I'm going to plug in square root of 5 for a. I don't know what b is, but I see that it is represented by the variable x, so I'm going to make this x squared. And I know that the hypotenuse is square root of 13, so I'm going to plug in square root of 13 for c. And I have my equation. So we know that if you square a square root, you just get the number into the radical. So this simplifies to 5. We still have our x squared, and then this becomes 13. To get x by itself, I have to subtract 5. So I'm left with x squared equals 13 minus 5 is 8. And then to get rid of this square, I got to do the opposite, which is square root. So I got to square root this. So x is equal to square root of 8. And let's see if 8 can be simplified even further. So I'm going to do my little factor tree. And I notice that it can be broken down into 2 and 4. 4 can be broken down into 2 and 2. And 2's are the most simple. So let's see here. We get 2 times 2 times 2. These 2's have twins, or are twins, excuse me. I'm going to take them outside the house. And I get 2 square root of 2. And that is my answer. So now that you've done this, you can go to page 22 of your packet, and you can try these problems out. The ones that say Pythagorean Theorem. Okay, the next thing that we're going to talk about is how to multiply. And sorry, let me make this bigger. How to multiply radicals. So go ahead and title your next section Multiplying Radicals. And let's see, I'm going to give a little hint here, or instruction. When you multiply radicals, you always multiply the numbers of each radical all under a square root. Okay, so multiply the numbers all under the square root. Okay, I'll do an example so this makes sense. Okay. So in our first example, just know that we have square root of 3 times square root of 7. How do we do this problem? Well, what you're going to do is you can actually put these numbers under the same radical, like this. It can become 3 times 7. And then you can actually simplify this and multiply these two numbers. 3 times 7 is equal to 21. And 21 can't actually be broken down any further, and so this is your answer. Alright, let's do another example. Okay, say like we have square root of 2 times square root of 8. Okay, we're going to combine these numbers under the same roof for the same radical. So we have 2 times 8. And we can actually multiply these out. So 2 times 8 is 16. And 16 is actually a number that can be simplified or broken down even further. And it's actually broken down into 2 and 8. 8 can be broken down further into 2 and 4. And 4 can be broken down even further into 2 and 2. And so this all becomes 2 times 2 times 2 times 2. These pair of 2's have a twin, or are twins, so you can take them outside the house. And these twins can be taken outside too, so then you get 2 times 2, which is equal to 4. And that's your answer. Okay. What if you had radicals that actually had numbers in front of them already? What do you do in this situation? Well, let's do another example. Say like you have 3 square root of 2, and you want to multiply that by 4 square root of 3. What you're going to do first is, trying to pick a different color here, is you're going to multiply the numbers on the outside of that radical or the outside of that house first. So it's going to look like this, 3 times 4. And you're also going to multiply the numbers here under the radical, under the same radical, so 2 times 3. And let's go ahead and simplify. This 3 times 4 is 12. 2 times 3 is 6, and 6 can't be broken down even further or simplified even further. So this is our final answer. One word of advice, these rules only apply to multiplying radicals. Some of you are probably going to try to do this. Square root of, like for example, square root of 3 plus square root of 7, and you're going to say, oh wait, doesn't that equal to square root of 10? It does not. This is wrong, and you can never do this. Okay? Let me show you why. Square root of 3 actually equals, if you were to do it in decimal form, 1.7. Square root of 7 in decimal form is equal to 2.6. And when you add these two together, they equal to 4.3. The square root of 10 right here is actually equal to 3.2. So as you can see, these two numbers don't match up, and so this method doesn't work. It only works for multiplying radicals. So now that you know how to do this, you can go to your packet, page 23, and at the top right here you can practice your skills.